Hi, in this video we're continuing on from the previous ones where we got AOE comms running to allow Connect to talk to the drives over EtherCAT. We then configured and tuned the drive using Connect. We'll then continue working on the TwinCAT project and add all the necessary setup and software to get the PLC to control the drive and motor. Now in this video we're getting a simple motion setup working using the CT NC axis interface library and in particular the MCCT position axis function block. In terms of the hardware, we've got a laptop, and that laptop has got Control Techniques Connect software loaded, and it's also got Beckhoff TwinCAT XAE shell loaded. There's an Ethernet connection through to our Beckhoff hardware, which in this case is an IPC, but it could be a controller or PLC from Beckhoff, it kind of makes no difference. So one of the ports on the device is set up for EtherCAT, and that's connected through to an SI EtherCAT, which is plugged into this drive, which is a UniDrive M700. Making this a EtherCAT capable drive. Now if you've got one of our dedicated servo products such as Digitat's HD M753, this interface is effectively built inside the product. So regardless of the way that the EtherCAT is interfaced to the product, the steps that you'll see throughout this demonstration are the same. So before we kick off into the technical part of the demonstration, I just want to point out that all of the useful information in this video and all of the others in the series is backed up in detail by a comprehensive user guide, which is linked in the description, along with the library that you would need in order to work with this. Just to recap on the point that we're at, we've got the very basics required to get ADS comms working and to allow Connect to work. Okay. So just as a recap, we've told it what our device is, we've scanned our devices, we've found our EtherCAT interface, which is the EtherCAT interface on the IPC. We've then told it to scan for boxes and it's gone and found the drive that's connected to it. We've then said yes to creating an NC axis. Okay, so if we look here, we've now got under axes an axis and the communications from the I/O is now connected into this axis, and we'll see that a little bit later. So because we're going to go make a load of configuration, I'm going to choose to go back into config mode. Let's click yes to those boxes. There we go. Okay, so first thing that we want to do is give ourselves a program space so that we can actually begin to write the software. So I'm going to right click on PLC and go add new item, standard PLC project, and then I'm going to make, I'll put it in my clipboard, get going TwinCAT. I'm going to go and add that. So it takes about, oh there we go. So there's our project, and we can see all the normal good stuff that you want to see when you're setting up a project. So we've got a POU, so it's already created a main POU, so you know that's somewhere for our program code to live. And we've got this section here which is references, which is effectively where the libraries live that we are interested in using. Now there's a number of them that we're going to have to set up, so I'm going to start at that point. So to add the basic libraries that you will need to go along with the Control Techniques NC Axis interface library, we need to add a few things. So we need to go to Motion, PTP, and we need to add all three of these. Now unfortunately you can't add them as a block, you've got to add them all individually, so I'm just going to go through that process now. PTP, the NC one, and advanced homing. Okay, the next one that we want to add in is the EtherCAT library, because we'll be using SDOs as part of that. So we need TC2 EtherCAT. You can actually search for it as well. There we go. Okay, next we actually need to add in the Control Techniques library. So if I go library repository, install, and then you hunt to the place where we have put the library. So in this case, I've got a copy of the library here. So I'm going to click that and click open. And there we go. That's installed the library to the overall repository inside TwinCAT. So we can close that, and now we can go and add the library. So here we go, add, and you'll see that there's a control techniques section. Expand that, CT interface library. Click OK. And there we go. That's all of the libraries referenced up that we need to get motion working. Next thing that I'm going to do is I'm going to go and set the task time to a millisecond, because they come in at 10 milliseconds, which is a bit on the slow side. So I'm going to take that down to a sensible rate of 1 millisecond. Just make sure I've got all of them. There we go. Okay, so that's all the places that we need to be interested in to set the rate to something sensible. So the next thing that we want to do is we want to go and put in some code. So let's go and do that. So I'm going to go to our main program and I'm going to add in an axis ref. So the one thing to point out about the Control Techniques NC Axis Interface Library is that really under the hood we're using the TC2 NC Axis Library. All we've done is put a wrapper around it to make it quicker and easier to get going, essentially, because if you're using PLC Open you will find that it's just a box of individual parts that you've got to go and connect up. So what we've done is we've done some of the legwork for you and made that happen. So if I show you, if I click on here and then go POUs, function blocks, and motion interface, you can see here are, in fact, there's 4 of them. So you've got a virtual axis. So if you're going to do like an electronic line shaft thing from a virtual reference, we've given you a block to be able to control that. We've given you one for EGB, which essentially is dressing up the MC gear in function block to do a electronic gear lock to another axis or to another encoder or to a virtual axis. We've got the position axis. So this is basically, you know, jogging, stopping, and various types of position reference, absolute, relative, modulo, all of the different options. And last of all, a more simple speed axis. So it's just got, you know, fast stopping, jogging, and then the machine running in an automated way at some speed. Now there are going to be some extra videos in the series that kind of run you through the options that you've got with each of these, but for the purposes of what we're doing, I'm actually going to be using the CT position axis. So let's go and set about doing that. So the first thing that we need to do, like with any PLC open type axis, is we need to have an instance of axis ref. So you need to do this regardless. Next thing, we want to add in our motion interface. So I'm going to say axis 1 position, and that will be of type MC CT position axis. And that's it. So what I'm going to do, because it's a bit easier to kind of play with the inputs and outputs from the point of view of just getting that sort of hello world axis turning, I'm going to go and add an action to my program, and I'm going to make that action run in ladder diagram because it's a bit easier to see the input. So I'm going to call this action motion, and there we go. Now we've got a place for our ladder code to hide. So last thing that I'm going to do is I'm going to call it. So now any code that we put inside here is getting serviced by our main task. So now we can swap over. So first thing that you want to do is you can right click and go insert. I just tend to grab it from here. And I'm just going to go and delete some of these extra inputs. So one other thing that's worth pointing out is that when you're using, there we go, so TwinCAT, PLC environment, FB and editor, you want this box to be ticked. So I'll just go through the tree. So it's options, TwinCAT, PLC environment, FB, LD and IL editor, and make sure that empty operands for function block pins is checked. If you don't, all of these pins will be filled with question marks that are a bit annoying to delete, so it's best to get that set from the off. So let's go and add our function block name or our instance name, which is axis 1 position. Boom, there we go. That's all of the setup that we need for that. You have to delete that remaining set of question marks, and then all we've got to do is route in our axis. So axis 1. There we go. And that's everything that you need to be able to do the basic setup. So next thing that we're going to do is go and do the axis configuration itself. So I'm going to click on here and go settings. So the first thing that you have to do, and you have to do this with an NC axis, you know, even if you're using like MC power and all of that, you still need to link to the PLC. So what this is doing, this is telling this axis, this NC axis, where is the axis ref that I need to link to. So just before I do that, I'm going to go and build. So build solution. And there we go. No errors, everything good. The reason that we need to do it before we go and set the link to the instance of axis ref is that if you haven't built, this axis 1 won't actually appear in the list and be selectable. So if I go to link to PLC, we can see that this is selectable. If you find that it's not there, it's probably because you haven't built. So I can go OK. So that's linked in. So next thing, we need to set up our axis scaling. So I'm going to double click on encoder because that's where the axis scaling is. And you can see that we've got two values here. You've got a numerator and a denominator. So the top one is a number of units. So units that you want your application to be in. It could be millimeters, microns, inches, thou, whatever. Okay. And then the bottom one is the number of encoder counts that represents the number of units. So there are a number of ways that you can set this up, but honestly the easiest way is to set it up so it's in encoder counts per revolution, because normally you know how many encoder counts you've got per revolution because it's usually written on the feedback device. So the default resolution that you will find is 16-bit regardless of the resolution of your feedback device. So what we need to put in here, 16-bit resolution is 65536 encoder counts per revolution. Next, we want to say, okay, we know how many encoder counts you've got for one revolution, but we want to know how many units that you've got for that one revolution, and that way we can convert back and forth between encoder counts and internal units using this ratio. Okay, so I'm going to use the arbitrary value of 1000. You can make it whatever it is for your particular machine, and what I'd also suggest is, just as a starting point, unless you want a rotary rollover to be something different, I would set your modulo factor here to 1000. So if you're doing something like a carousel and you know you've made your number of units per rev 360, you know this defines what your rotary rollover for a modulo movement will be if you're using something like MC move modulo. So that's everything for scaling. Now let's get back to the other properties for the axis. So I'm going to go to parameter this time, and we've got a few things to configure here. So the first one is the maximum velocity. So if I come back to our Connect project and we go to references, you can see that the maximum speed reference that our axis will accept from TwinCAT is 3000 RPM. But what we need to do, because in the TwinCAT environment it's in technical units, we need to convert 3000 RPM into our internal units per second. Okay, so if I fire up the calculator, we have 3000 RPM, and we need to convert from revolutions per minute to revolutions per second because the units here are all per second. There are 60 seconds per minute, so we need to divide by 60. And there we go, 50 revolutions per second. Okay, now we need to turn it into units per second. Now we know that this is 50 revolutions per second. We know the number of units per revolution is 1000 because we've just set that. So we need to times this by 1000. And there we go, 50,000. So that's our maximum velocity limit, and I'm going to go and enter that now. 50,000. I'm going to use it here as well. Now the next one, by default they give you a relatively low acceleration limit, and if you go over this limit you will end up with an implicit stop, which is not very useful when you're aiming for that hello world moment and you're fiddling about with your axis trying to get used to it. So my suggestion is, certainly in the first instance, and really only if you've got a particular reason to limit the maximum acceleration. I would set this so that it's so far out of the way that it won't cause you any problems. And one way in which you can do that, and the way that I use, is by setting this to 1 with 20 zeros. So 1e plus 20. And there we go. So I'm going to do the same again here. 1e plus 20. There we go. Next thing, I also want to set the default jerk to a very large number as well, simply because if you put 0 as the default jerk, you want to be able to make it so that it gives you a linear profile. So a very, very large jerk gives you a linear profile. So let's do that. There we go. Okay, so last thing, we want to adjust the monitoring, and unfortunately these default values rarely work out for your axis. Normally they'll cause you an implicit stop. So what will happen if you forget to set these to false, you'll go for a little bit of a move, the axis will move by about 5 millimeters, and then it will stop on an NC axis violation because the following error will have been too high or something along those lines. And it's simply because these are just a starting point, you know, they're not a true reflection of the general following error that you've got on your axis. So just to begin with, you can come back and set these later. I'd highly recommend setting these to false so that you don't end up with any implicit NC axis stops. So I'm just going to set all these to false. You can come back later and set them later. So there we go. That's everything that needs to be set up for the axis, and I'm going to go and activate the configuration. So we'll give that a minute. We'll just wait until we get the. There we go. Okay. Wait for the green box. There we go. I think that's now working. Oh, sorry, I've forgotten one thing. Let me come off. One thing that you don't necessarily have to do it unless you're using touch probe or freezing, but I'll show how to do it, because we actually set up capturing of data from the axis. We also need to set up our touch probe. Come on, here we go. Right, okay, so we need to go to process data, and we need to select this one. So 1A02, that's the PDO data mapping place for things coming from the drive, okay? And what we'll need to map in is all of the touch probe data, because it doesn't come in by default. So let's go and add that. So add new item, and you'll see here that you've got a list. What we need as a minimum is touch probe status. We'll do the next one, add new item, touch probe 1 positive edge. And then we also need a new item, touch probe 1 negative edge. That way you've probably got the most useful scenario. So you can use touch probe for homing, you can use touch probe for just simply sampling what your axis position is, whether it's on positive edge or negative edge, and it's the kind of the minimum that you need. So last of all, we want to go to this one, OX1602. So that's items going to the drive. So again, we want to click in an empty space and go add item, and we only want one thing from here, which is touch probe function. So this is the control from over the DS402, which is like the interface layer that's used beneath EtherCAT in order to control the drive. We need its control word for the touch probe function. So there we go. That's everything. And then now I'll activate the configuration. We should have everything that we need. And crucially, no errors. There we go. Okay. So we're working. We can see that Connect is working. You know, we're online. We're able to see stuff. So next thing that we want to do is we want to go to our main motion and we want to log in, go online. Now, what you can see here is that we have got a relatively nice interface. There's quite a lot in here, but there's a lot of references that we set up for you by default. So we've got the ability to turn the drive on and off. We've got the ability to reset the axis, so this is both resetting the drive and resetting the NC axis itself, so the resetting the PLC open state machine. We've got fast stopping reference, we've got jogging forward, jogging in reverse, homing, home switch input to go with the home, and commanding position, saying whether we want to enable software limits, resetting freeze flag, and the PLC open error reporting that we've got here. On this side, we can tell whether the cyclic comms are working, so this is SDO reads and writes. We can tell whether the axis comms are ready, so that's whether EtherCAT overall is working properly. We can tell whether the drive is on, so that's is it enabled and in run, which at the moment this says it is not enabled and in run, and that's confirmed by the fact that the drive is in inhibit and connect. So this is just giving you programmatic ways to tell at a glance what's going on with the product. So what we're aiming for here is to just enable the drive. So if you look, you can see this is our STO input. So this is I've taken away 24 volts from the STO input. I've now applied it, and you can see that we can tell that the drive is ready to do some work. So what I'm going to do now is I am going to say drive on. And there we go. We see drive on, and we can also see from the Connect world it's now in run. Okay, so pretty easy to use to get going. Next thing that we want to do is cause the axis to jog. So we haven't got to set anything. There's some default rates in there that are reasonably slow. If I bring on my camera and we go jog forward, double click on that, apply it, there you go. You can see that we're jogging. So if I change these, you're able to swap the direction. And there we go. That's probably the extent of it that we'll get to for this particular video. It's just hello world to show you these are the steps that you require just to get it going. Everything else after this is more about what you actually want to do in your machine. Do you want to connect up some physical hardware to the jog commands? If you want to do some indexing, you need to go and use the position reference inputs, go and set your target, set whether you want it in relative or absolute mode and whatnot. And as I said before, all of this is all kind of covered in the manual, and there will be a further video that gives a general overview of not only this function block but all of the other ones in the series. In the next video, we'll look at how to tune the position loop and finish the setup, which will include generating a startup file so we can protect the setup for the drive. Okay, hope you found this useful. Thanks for watching.